Today, the question for business telephony at any scale is no longer whether to switch to voice over IP, but when. The most important factor that has moved VoIP into the mainstream is improved quality of service. Businesses that have held back because of VoIP's early reputation for poor voice quality need no longer be concerned that important transactions such as sales will be impeded by poor quality of service, or that their company will make a less than fully professional impression on callers with VoIP. Today, excellent quality of service can always be achieved with VoIP, but it's not guaranteed. QoS ultimately depends on the switches that control the VoIP traffic, and of course, the network over which that traffic travels. It's understandable that the focus of attention in a transition to VoIP is typically on the service provider, the delivery model, on-site versus hosted, and the IP phones. But the switches have the most impact on the user experience. With NETGEAR switches, VoIP traffic can be automatically prioritized to maintain the desired quality of service, even when the network is saturated. A successful VoIP network with reliable QoS has voice packet prioritization. NETGEAR switches accomplish this automatically. Adequate bandwidth, both network and switches. Resilience, network switches with alternate power supply. Security, the network must be protected from hacking, including physical hacking. Regarding network planning, the number of IP phones combined with the need for a fast Ethernet versus gigabit connection will in turn determine the bandwidth and power requirements for the switches. NETGEAR recommends 2 lines of managed switches for VoIP networks. The NETGEAR Intelligent Edge M4100 series are fast Ethernet and gigabit Ethernet access layer switches with several gigabit ports for uplink functions. The NETGEAR Next-Gen Edge M5300 series are gigabit Ethernet switches with embedded 10 gigabit ports for uplink functions and virtual chassis stacking. Determining which switch within these 2 families requires answering 4 questions. 1. Will the IP phones require a fast Ethernet port at the switch or a gigabit Ethernet port? Today's high-end state-of-the-art phones often have 2 ports, one that connects to the switch and another that connects to a co-located PC. If the co-located PCs on the network require gigabit speed, then of course a gigabit switch is required. Number 2, what is the average bandwidth required per IP phone? Number 3, how many IP phones will be on the network? And 4, what is the total bandwidth required per switch? Virtually all IP phones are designed to accept power over Ethernet. There are 2 versions available, PoE and PoE+. To determine which switch in the M4100 or M5300 family is required for a particular installation from a PoE perspective, you should ask the following questions. How many watts are required per IP phone? How many IP phones will be on the network? What is the total wattage requirement? This reference design will provide general guidance on how to plan a highly reliable and cost-effective VoIP network. The network was designed with 4 criteria in mind. Simplicity, to enable easy installation and management. Voice packet prioritization, to ensure that a high level of QoS will always be available. Resilience, to ensure the 24/7 coverage that's a requirement for a business-critical function like telephone service. And security. This 200-phone installation would be typical for a mid-sized business or an enterprise-scale call center. At the access layer, each switch connects to 40 phones and also powers them via PoE. At the distribution layer, virtual stacking technology is used for high-performance and highly redundant distributed link aggregation. This installation consists of several IP subnets and associated VLANs, but without Layer 3 routing complexities. QoS settings are enforced by the switches across the entire VLAN network. This design delivers a highly available network that provides uninterrupted connectivity. It incorporates a level of redundancy such that there are no points of hardware failure. Further, critical components can be swapped without interruption of service. The switches can be configured with a unique, easy-to-use, web-based interface as well as the industry-standard command line interface. The IP phones are auto-discovered, and this network design avoids the use of the spanning tree protocol, which is complex and difficult to configure. The network's distribution layer allows for the best of both worlds with redundant links, as well as advanced load balancing and seamless failover. The switches handle packet prioritization to deliver high QoS. In this design, the switches are all equipped with a redundant power supply in the unlikely event that a switch power supply should fail. The design offers multiple levels of security, including port-based, access control lists, and radius. And NETGEAR switches support MAC authentication bypass for non-radius-aware endpoints. NETGEAR has the only solution with a fully functional interface along with an industry-standard command line interface. Let's discover how to configure the switches with an example of quality of service using both CLI and GUI. Raise the VoIP traffic priority and enable the voice VLAN feature. Send VoIP traffic with .1p priority of 5 and map priority 5 to Q5. Create a diffserv class map policy to provide QoS for voice traffic on the phone ports. This policy will be copied onto all stacks in the LAN network supporting VoIP devices. Here we go into the diffserv configuration mode. We create a diffserv class for the diffserv policy and queue VoIP traffic on the protocol level. We enter the VoIP class name with the class type parameter set to all. We match protocol type with UDP, and we match IP DSCP with EF. Next, we apply the diffserv class to a policy map. We enter the VoIP policy name with policy type set to in. Then we assign the VoIP policy queue value to 5. Configure the phone ports with voice VLAN 100 and data VLAN 200 and apply the VoIP policy to the phone ports. Now here is an example of how to configure the switches for QoS with NETGEAR's fully functional, easy-to-use GUI interface.
Enable the voice VLAN feature globally. Choose Switching, VLAN, Advanced, Voice VLAN Configuration. Enable Admin Mode and select all interfaces to support phones. Change the interface mode to VLAN ID and set the value to Voice VLAN 100. Click Apply to commit the changes. To queue and prioritize VoIP traffic properly, change the 802.1p queue mapping. Choose QoS, COS, Advanced, 802.1p to queue mapping. Select All from the Interface Selection drop-down menu and change the queue value to 5 for 802.1p priority 5. Click Apply. Assign queue priority to the phone ports. Choose QoS, COS, Advanced, Interface Queue Configuration. Select all phone ports, change the queue ID to 5, and change the scheduler type to Strict. Click Apply. Enable the diffserv feature. Choose QoS, diffserv, Advanced, diffserv Configuration. Enable diffserv admin mode and click Apply. Create a diffserv class for the diffserv policy and queue VoIP traffic on the protocol level. Choose QoS, diffserv, Advanced, Class Configuration. Enter the VoIP class name, change the class type to all, and click Add. When the class is created, click the class to open the VoIP class configuration page. On the VoIP class configuration page, notice the various settings that can be applied to the class. Click Protocol Type and select UDP from the drop-down menu. Click Apply. Then click IP DSCP and select EF from the drop-down menu. Click Apply. Next, click Class of Service and select 5 from the drop-down menu. Click Apply. Apply the class to a policy map. To create the policy map, choose QoS, diffserv, Advanced, Policy Configuration. Enter the VoIP policy name, change the policy type to in, and change the member class to the VoIP class you created. Click Add. When the policy is created, click the VoIP policy to enter its configuration page. On the VoIP policy configuration page, change the assigned queue value to 5 and click Apply. Apply the policy to all phone ports. Choose QoS, diffserv, Advanced, Service Interface Configuration. Select all phone ports and change the policy in name to the VoIP policy created. Click Apply.
NETGEAR managed switches offer a secure, future-proof networking infrastructure for mid-size organizations and campus networks. But why NETGEAR? Competitors like HP and Cisco focus on enterprise and data centers, fighting against Brocade, Arista, Force 10, IBM Blade, and Juniper. When it comes to mid-size organizations, they have to repurpose and dumb down their solutions to meet the price demands while justifying them. And in spite of a significantly reduced feature set, they are still quite expensive and complex to deploy and maintain. We at NETGEAR provide better value by building our offerings from the ground up and not the top down, so that by adding new features we are reaching up to new companies and not worried about protecting any enterprise business reaching down to smaller markets. We continually strive to simplify the management of our solutions. In addition to a real industry standard CLI, all our managed switches come with a fully functional web management interface, not just a dashboard, which makes us easier to use and more attractive to SMB and distributed branch enterprise companies. Last but not least, we systematically lower the overall acquisition and lifecycle costs with things like 10 gigabit built-in uplinks and industry-leading lifetime warranties and technical support. For more detailed information, visit netgear.com and download the Networking Solutions for VoIP Guide and the detailed application note, or call a NETGEAR representative.